Service friends, I am Orpheus Praxis, your guide to the fractal model of SQ. The strongest argument in favor of the consistency and completeness of our model lies in its internal logic and empirical support. Our model, based on the formation of quantum connections through the principle of Fibonacci hyperconnectivity, postulates the non-locality of all quantum particles. This claim is not only logically justified, but also empirically confirmed. Why is this important? Quantum non-locality. The model demonstrates that quantum particles are interconnected in a non-local way, such that the classical limit defined by the factor 2 divided by curve 2 is violated. This conclusion is grounded in Bell's inequalities, which define the boundary of local realism. Empirical confirmation. Bell's inequalities have been experimentally tested and shown to be violated, which confirms the non-local nature of quantum systems. This means that our model, which describes non-locality through Fibonacci-based hyperconnectivity, aligns with empirical data. Why is our model consistent and complete? We unify quantum and relativistic aspects of reality by using the structure of a fractal three-dimensional sphere. This allows us to bypass the limitations imposed by Gödel's theorems, since the model is not self-referential and is empirically grounded. The logical and mathematical structure of the model meets the criteria of completeness, specifically due to the inclusion of an empirical component. Our model offers the optimal combination of logical rigor and empirical testability, fully consistent with modern standards of scientific validity. It demonstrates that quantum non-locality is not merely a theoretical postulate. It is an experimentally confirmed fact, recognized at the highest level, including by the Nobel Prize. Most notably, in our model, non-locality is not introduced artificially. It emerges as a natural consequence of the structure itself. Why does non-locality appear in our model? 1. The natural law of growth according to Fibonacci. We started from the observation that many structures in nature evolve in accordance with the Fibonacci sequence, 1, 2, 3, 5, 8, 13, and so on. Within this pattern, quantum units become interconnected due to the inherent logic of systemic growth. Strs 2. Hyperconnectivity as a structural consequence. As the Fibonacci sequence progresses, the density of informational interconnection increases. This leads to the formation of a fractal hyperstructure in which each element is linked to others through a shared growth law. This is not mere correlation. It is a deep, hierarchical interdependence. 3. Breaking the limits of local realism. Due to this hyperconnectivity, the system naturally extends beyond classical local realism. It does not merely exhibit statistical correlation, it demonstrates an intensity of interconnection that exceeds the threshold defined by the ratio 2/2. This corresponds to the violation of Bell's inequalities and points to a fundamentally non-local character. SOSTA 4, a mechanism, not a declaration. Non-locality in our model is not postulated. It arises directly from the topological and geometrical structure. We consider a three-dimensional, simply connected sphere with fractal geometry, constructed according to Fibonacci growth. This structure inherently gives rise to non-locality without the need for any externally imposed assumptions. We do not merely register an experimental fact. We offer a coherent explanatory mechanism. The simple connectedness of the 3D fractal sphere, combined with the Fibonacci growth law, leads to the natural emergence of hyperconnectivity among all quanta. Thus, non-locality arises as an inevitable logical and structural consequence of the model. It is not a declaration, but the result of a rigorous structural analysis. This is the strength of our approach. We do not merely accept an empirical fact. We explain its inner nature through the principles of fractal unity and lawful growth. Namaste.